So in the guide for writing the lab report, this is the information that you're going to have to include or calculate any test that you're going to have to analyze for the lab report. Number one, you're going to have to come up with an average and standard error for the depth, temperature, and salinity at 15 and 20. That's simple enough. There's not really anything you have to do with those, but just report them. And then you're going to have to come up with the average and standard error for wet and dry weights for the sediment core. And then you're going to create a table. This is where you do for each sediment grain size in microns and the corresponding phi size, which you can find in your sediment grain analysis or your sand grain size analysis. So you're going to create this table with your sediment grain size and your phi size, and you're going to report the percent dry weight. This is for, again, each one of your sediment cores. So, like for instance, at the top of the table, you might have the sediment grain size, and below that the phi size, and then below that you're going to go ahead and have the percent dry weight for each one of those categories for each one of your 6 cores. Then, number 4, for each of the 6 sediment cores, create a graph with grain size fraction on the x-axis, cumulative dry weight on the y-axis, and connect the lines. It's going to be a cumulative dry weight graph curve. Use this graph to calculate the median grain size, the mean grain size, and sorting. And to do that, you're going to go ahead and look at these documents, the sediment grain analysis, or sand grain analysis, and then also the calculation of grain size stats and parameters. If you go ahead and look, number 1 in the sand grain analysis handout, you're going to go ahead and you flip through it, you're going to basically create a cumulative probability curve, cumulative probability curves, and here's an example also of a cumulative probability curve right here, where we have the grain size, the phi size, and the percent dry weight. Oh, that's not, I'm a liar, I'm a liar. Okay, strike that graph I was just showing you. Okay, this, hello, this right here is the cumulative probability curve. Here we have grain size, hold on a second, and cumulative dry weight. Cumulative weight percent, for instance, if you look at that one, like those two, here's the cumulative probability, Here we also have another cumulative probability on the lower left. Also take a look at these. Take a look at the bottom graph. Take a look at those bottom graphs. So those are going to represent these cumulative probability curves. And so that's basically what you want to do with it. Also, if you look at this, we've got the cumulative percent and the phi size, that graph. This cumulative percent and the phi size, that graph is in this sand grain analysis handout, is also showing you what you, the type of graph that you need to make, and information that you're going to go ahead and gather from it, because we're going to need to make these graphs and then get information from that graph to calculate or determine our median, mean, grain sizes, and our sorting. And then, to do that, to calculate these things, we're going to use, again, this handout, the calculation of grain size, statistics and parameters, and you'll notice that if you look down, we have information about how to get the median grain size, a formula about how to get the mean grain size, and then for sorting, we also have how to calculate and get the sorting coefficient. So in this particular case, the median grain size is going to simply represent the 50th percentile. So when you get this cumulative graph, like we see right here, here's our cumulative graph, this one right here. If you go at 50% and you follow that over to the line, and you drop down from the line to the x-axis, which is in this case phi size, then you're going to see what that size is, and that's going to be your median. So it's relatively easy. You just look at the graph once to get your median, and let me show you briefly. So here's your cumulative probability, right? Here's 50%. You follow that over and drop straight down from the line. That's your median grain size. Pretty easy. Half of the grains are bigger, half the grains are smaller. But to get the mean grain size, it's a little bit more complex. And if you look at the formula for the mean, you see that we have to determine what the phi is not only at 50, but the phi at 16 and the phi at 84. And then we're going to divide by 3 because we've got 3 different numbers. And so if you take a look at this graph again, not only do you get the value for 50, but you get it from 84, and you also get it from 16. Do you see where I'm talking about? So all the way up here, and then all the way down here.
So those are the values you want us to use?
That's right. You would use for that the phi size of, so you follow over to the line and drop down, and then get those phi sizes and use those phi sizes.
So that's just standard.
That's, yeah, that exactly. And so that's for the mean. Again, the mean grain size is the phi size of 16 plus phi size of 50 percentile and phi size at 84 percentile divided by 3. The sorting, remember when we talked about sorting, we talked about the fact that sorting is going to relate to how well the sand grains are distributed across size classes. And so something that I said that was well sorted means that you only really have, like I would say, one sand grain size predominating. Something that is not well sorted or poorly sorted has every different type of sand grain represented. And so we want to go ahead and calculate the sorting. And if you look at the sorting equation, you'll see here that we've got the sorting coefficient being equal to the phi size at 84 on your graph, the phi size at 16 on your graph, divided by 4, plus the phi size at 95 and the phi size at 5, divided by 6.6. So that's going to be your sorting value. And then based on that, if you continue to read for the sorting, it then will go ahead and explain to you what your value represents. Something that it could be very well sorted to something that could be poorly sorted. Okay, so whatever value you get is going to go ahead and indicate how well sorted your sand is in each one of these these cores that we took. So again, just looking at this graph again, if you take a look at that graph, it shows you where you would go for 95, follow it all over to the line and drop down 84, 50, 16, and 5. So to get everything that you need, those are the things that you would have to look at. And so one of the first things you're going to have to do then is start by making these graphs, figuring out, making these graphs, and figuring out percentages, and then making the cumulative graphs. Okay, so let's get back to this. Let's get back to the guidelines. Let me see where I am in the guidelines. Number 5, determine an average and standard error for the median grain size, the mean grain size, and sorting for 15 and for 25. So you'll have, 3 median grain sizes at 15 and 3 at 25, and again, you'll go ahead and you'll determine your averages and standard deviations. And then what you're going to do is you're going to go ahead and create graphs showing the means from 5. And then you're going to go ahead and do 3 t-tests This is a statistic that you will calculate to see if there are differences between the mean grain size and the median grain size and the sorting at 15 and 25, and I'll show you that in SPSS. So then, now that we're done with the sediment, we're going to move on to the plants that create the habitat, and first we're going to determine the average percent rhizophytic algae, seagrass, and sand at 15 and 25. And then for each one of those, you're going to do a t-test to determine if they are different from one another at 15 and 25. And then you are going to determine the average number of shoots of turtle grass, manatee grass, and shoal grass at 15 and 25. And then you're going to also do 3 t-tests to determine whether or not each one of those species is different at 15 and 25. And then you are going to determine the average and standard error for root and shoot dry weight at 15 and 25 from the shoreline and do 2 t-tests, one for roots, one for shoots, to determine if there's a difference between 15 and 25. And then you're going to go ahead and create bar graphs for any of the above for which you found significant differences. So that could be as few as none, or it could be as many as all of them. And I have no idea because I have not yet analyzed the data.
Awesome.
So we will see. If you do not find significant differences, you should still report the information. You just need to make a graph. So definitely report that that you didn't find a significant difference, and give the test statistic and give the p-value, and then just say there was no difference, no significant difference. Next, let's see.
We only have 3 t-tests.
For that one we have 2 t-tests.
2 t-tests.
That's right. For the root and shoot, we have 2 t-tests. But now we're going to move on to the animals. So at 15, we're going to get the average and standard error for the epifauna abundance and also for richness at 15 and 20. And then we're going to do 2 t-tests. We're going to do a t-test for differences in epifauna abundance between 15 and 20, and a t-test for epifauna richness at 15 and 25. Then we're going to get the average and standard error for infauna abundance and richness at 15 and 25, and again do 2 t-tests to determine if 25 and 15 are different from one another. Then you're going to get the average and standard error for fish activity at 15 and 20, and do 1 t-test determining whether or not there are differences in fish activity between 15 and 25. And then you want to make bar graphs for any of those for which you find significant differences. And so I'm not sure, but looking at the data, it's possible that we could find some that are different and some that are not. She's laughing at me.
I think she died a little bit inside. It's part of my soul left in my body.
And then the next part, we are going to test for a correlation between mean sediment grain size and infauna abundance and richness. And then we're going to test for a relationship between mean wet root biomass and infauna. And then we're going to test for a relationship between epifauna abundance and percent seagrass, number of shoots of each species of seagrass. We're going to test for a relationship between fish activity and percent seagrass and the number of shoots of each seagrass. And then we're going to explain whether conditions were significant, or whether correlations were significant, positive or negative, and whether they were weak, moderate, or strong. If the correlations are somewhere around 0.1, 0.2, 0.3, that's weak, 0.4, 0.5, 0.6, that's moderate, 0.7, 0.8, 0.9 something, that's strong. And the same thing if you have negative numbers. So -0.1, -0.1, -0.2, -0.3 weak, -0.4, -0.5, -0.6 are moderate, -0.7, -0.8, -0.9 are strong. And then you would want to make a scatter plot for any of the above for which you found significant correlations. So I have no idea if we're going to find correlations or not for those. So that will be really interesting. And then there's some information that you want to make sure you address in your discussion. This is not the entire thing that you want to discuss in your discussion, but it's certainly things that you do want to address. So for instance, like I did not write anything in here about error or anything like that, or new things that you might want to do, new studies that you could do, but I certainly wrote about or wrote some things here about like trying to relate what you find with the seagrass to the infauna, and trying to relate what you find with like the fish in the epifauna to the grass itself, and trying to understand whether or not the grass is important. So I think the main thing that we're trying to answer here is whether or not the seagrass is going to go ahead and promote abundance and richness of animal species. Is it going to serve as do they serve as a good habitat? Why do they serve as a good habitat? So you want to talk about these things. So, so now let's go ahead and